So this is for the third week of AI problem solving through such methods. While coming to the group 1, we are having the graph like this, and they had given the questions. First one is in the map, consider S as your start node, and they are asking you to list all the nodes, all the next 6 nodes starting from 2 to 7 by using the breadth first search algorithm. So if you see, this is your start node, S is your start node according to the breadth first search. So first see what are the nodes connected to S. So the nodes connected to S are A, C, I and K, and they mentioned that the move-gen function returns neighbors in alphabetical order. So whenever you take this node S, we expanded the node S or the inspected the node S, then the move-gen function of S generate the nodes in the alphabetical order. So you need to mention the nodes in the alphabetical order. According to BFS, the nodes visited are first S. They didn't mention, ask you to mention the S. So we'll start from the node 2. That is, next node is A, next C, next I and K. So these are the A, C, I, K are the nodes now in the open list. This will go to the closed list. Next, the node in the open list is the first node is A among A, C, I, K. So we'll see what are the nodes connected to A. So the nodes connected to A is only B. So we listed B. Then C, we are having the next node is C. So what are the nodes connected to C? C, we are having I and D. So according to alphabetical order, we write D. So next D, but already I are already there, is there, no need to write. So B, D. So these are the first 6 nodes by using the BFS algorithm. So first you need to write all the nodes connected to S, then we'll take one by one from the open list and expand and write according to the alphabetical order. Next, they ask you to which node has the largest heuristic value, and they ask you to calculate by using the Manhattan distance for calculating the heuristic value. First, the heuristic value meaning is the estimated distance from a particular node to the goal node. So if you consider V as a node and the h of n, that is the heuristic value for V is, we need to calculate 1, 2, 3, 4 and 5. So whenever we are calculating Manhattan distance, you need to travel parallel to x-axis and parallel to y-axis. You can follow anything. 1, 2, 3, 4, 5. So each one is having 10, so 50. If you follow like this, 1, 2, 3, 4, 5, 50. Both are same. You can follow like this, either parallel to x-axis or parallel to y-axis. If you consider R, 1, 2, 3, 4, 5. Otherwise 1, 2, 3, 4, 5. You can go in any direction. So 50. For n, 1, 2, 3, 4, 5. Otherwise you can go with this 1, 2, 3, 4 and 5. You can. So like that they are asking us to calculate which node is having the highest heuristic value. So if you consider this one D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. So it is having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now consider the node B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So the node B is having the highest value as heuristic value B and comma the value we are writing to 10. So each is having the 10. So while coming to the third question, they are asking us to calculate by using the start node S and the next 4 nodes starting from 2 to 5 by using the best first search algorithm. According to the best first search algorithm, the heuristic value f of n, the function value f of n is equal to h of n. H of n is called the heuristic value of the node n. So estimated distance of node to the goal node. So according to best first search, we will consider the node which is having the least h of n value. That is the node which is very nearer to the goal node. So they ask us to yes, starting from yes. And before starting, we have to calculate all the h of n values for all the nodes. Okay, so starting from yes. S is connected to A, C, I and K. A, C, I, K. So this is connected to A, C, I and K. So we'll follow open list and the closed list concepts. Now S is node is already visited, and now A, C, I, K move to the open list. So in the ACIK, A is having 200 and C is having 170 and the I is having 120 and K is having 150 heuristic values. So among this one, I is having the least value. So I will be moved to the closed list. Now we are having ACK already in the open list. Now after moving I to the closed list, whatever the nodes connected to I is added to the open list. So I is connected to SCHML. SC already completed. So we won't add the nodes which are already there in one. Now we are having HML. So it is connected to H, M and L. H is having the 100 heuristic value, M is having 80, L is having 100. So now ACK, HML are in the open list. Among this one, M is having the least one. So we will move M to the closed list. And now we are having ACK, HL and M is connected to HIL. So already all the nodes are there. Okay, so no need to add any nodes in the now to the open list. So among these nodes, next we will select which is having the list. So next H is having the list. So next we will visit the H. So next H will be moved to the closed list. Now we are having ACKL and H is connected to DFIJM. Okay, so we are adding D, F and J. So D, F and J. So F is having 130, G is having 160 and J is having 90. Now among all these things, so which is having the least value is J. So we are moving J to the closed list. Now we are having A, C, K, L, D and F and J is connected to N and H. So H already completed. Now we are adding N. So N is having the heuristic value as 50. Now among all these things, N is having the least value. Now N will be moved and it will repeat and so on. So they asked the four nodes. So starting from S, I, M, H, J, M. So these are the. So we need to write I, M, H, J. They asked only to write 2 to 5, 2, 3, 4, 5, J. Okay, no need to write N also. I, J, I, M, H, J. So this is the nodes following according to the best first search. Next, fourth question, by using the hill climbing algorithm, starting from S again, they are asking us to write the nodes from 2 to, so whatever the nodes from 2 to 5 by using the hill climbing algorithm. So according to hill climbing algorithm, hill climbing, whenever the node moves to the next node, if it is a better node, then only it will move to the next node. So starting from S is connected to all these nodes. If the heuristic value is better than the S, better means very nearest to. So meaning that if the H of n is lower when compared to S, then only it will move to the next node. So if you follow the same procedure, so S is connected to S is connected to S is connected to A, C, I and K. So S is having the heuristic value 70 and A is having 200, C is having 170 and I is having 120 and K is having 150. So it will move to a node which is the better node when compared to the S. So I and K both are better. Among I and K, which is having the lowest is I. So next it will move to the I. So first S, then move to the I. So best. Next I is connected to L, M 110, m is having 80, and s is having 100. And better node next is m. Okay, so next it will move to the m node. Okay, next if you see after m, the nodes connected to m are HIL. Okay, after m, the nodes are connected to H, I, and m is connected to H, I, M. So H is having 100, 120, 110. So we are not finding any best node after m. So the algorithm will terminate now. So the hill climbing will move from S to I to M, then it will stop. Okay. So according to hill climbing algorithm, so the answers are I and M. They didn't ask us to write the yes node starting. So next to 2 for 5, but it terminates in the middle itself. Okay, so until inspected until the termination, but the termination happened at the node M because the node M is connected to HIL. Okay, so yes, then it is moving to I. Then I is better when compared to all the nodes. Then I is connected to HML. So M is having the 80. Then M again we are not having any other nodes. If you see, M is connected to H, I, and L, which are having a higher values. So it will be stopped here. This is the local minimum we will get at hill climbing. Okay, sorry, local maximum. So there won't be stop. So M will be terminating point for this algorithm. So IM. While coming to fifth question, for the given map, which algorithm finds a path from the node S to Z? So depth first search, breadth first search, and best first search. Just now we saw hill climbing, don't find the algorithm. So these three are the answers. Now for the given map, try and find a TSP traveling salesman tour problem using only the edges in the map. Choose the correct options. So traveling salesman problem, we have to start from a particular node and we have to reach the come back to the same node, but they should not follow any loops. Okay, so if you see S, A, B, C, again we're having so many algorithms like nearest neighbor like that. So here by traveling salesman problem, if you see, if you follow anything, so we will find a solution without following any loops. That is the found one tour, and there may be definitely more than one tour also for traveling salesman problem depending upon different algorithms. Next, while coming to the seventh one, for the given city map starting from S and only the given edges using the Euclidean distance, the edge cost, construct a TSP tour using the nearest neighbor algorithm. So now here we have to use the nearest neighbor. So nearest neighbor means assume that we are having the S. We need to visit the nodes. If you see S is connected to A, C, I, K. According to nearest neighbor, we need to see which node is nearer to S. That node we have to visit. Previously we saw the Manhattan distance. Now we need to follow the Euclidean distance. Okay, so Euclidean distance between S and A is, so this is the Euclidean distance. Now we need to follow like this 1, 2, form a triangle like this. Okay, so this distance, if you want to calculate the Euclidean distance, so like Pythagoras theorem, AC square is equal to A. If you consider A, B, C, AC square is equal to this one, AB square plus AC square. So square root of AC square is equal to square root of AB square plus AC square, like that. So this is the, and now consider the square root of this distance. So this is 2 square root of 2 plus 1, 4 plus 1, 5, square root of 5, this is 5. So now consider SB like this, SC, which is having the least. Like this we follow S to A, then S is having very nearest neighbor is A, then A is having very nearest at B, then B is automatically C. Like that if you follow, will struck in between, can't able to find by using the nearest neighbor. Okay, so that's why nearest neighbor algorithm fails to find too. Okay, if you follow that finding the Euclidean distance and search for that. While coming to the group 2, this is the given Boolean function f is equal to, and these are the a b c d. We are having 5 a b c d e as variables, and this is the h of n evaluation. H of n, here we are having the 1 2 3 4 5 6 classes, and the h of f value can be how many these classes are satisfied. Here you see 1 2 3 4 5, that's why they kept as 5, and evaluation value is if all the values, if you see this is and all these values are 1, then only you will get it is a 1. So here 1, C and R is 0. So 0 and 1 is 0. That's why you got here 0. Like that, they had given all the functions for all the different values, and they asked us to calculate starting. Let S is equal to this one. This is our starting, and these are the nodes or the neighbors generated by them. Just the neighbors are generated here by changing a single bit. So first, if you change the first bit, so we'll get 1 to 0. So 0 0 1 0 1 0 0. So if I change the second bit, so 0 change it to 1. So 1 1 1 0 1 1, like that, 1 1 1 0 1. Next third bit, fourth bit, fifth bit, like that we will get the 5 neighbors, changing each bit. So now they are asking enter the three heuristic values of S, B, E respectively. So for S, that is 1 0 1 0 1 1 0 1 0 1 0 1. So this is, they are asking heuristic value, the number of count 1 2 2 are there. So enter 2. Next for B, triple 1 0 1 triple 1 0 1. So how many? 1 2 3. So next enter separate comma 3. Next they are asking for E, 1 0 1 0 0 1 0 1 0 1 0. How many? 1 2 3 4 are there. So next 4 enter. So these are the H of n values for SBE. Okay. Next, use the Boolean search with the width 2 to solve SAT problem. Consider 1 0 1 0 1 as your starting. Okay. So if you start from the 1 0 1 0 1, so yes, we are having yes is 1 0 1 0 1. Okay. So h of n, this is for h of n is 2. We are having h of this is your. So neighbors will get by changing. First, if I change the first bit 0 0 1 0 1. Okay. Next, by changing the second one 1 1 1 0 1. Third one bit 1 can be 1 0. Third bit 1 is 0 0 1. Next fourth 1 0 1 1 1. Next fifth 1 0 1 0 0. These are the neighbors we will get for the yes. Okay. So if you go and see in the table, this is having the heuristic value 3, and this is having 3, and this is having 4, and this is also having 4, and this is also having 4. Okay. Now, so they had given the beam search with us. So we need to select the 2 from these, which are having the highest values. Now we had 3 values. Whenever you are having 3 values, you follow according to the alphabetical order. So select this one, numerical value, and 1 0 and 0 0, least values. Okay, these two are the next to visit. This in the level 1. Okay, next similarly follow this. Okay, so what are the nodes connected? In first node changing 0 0 0 0 1. So next if we change the second one 1 1 0 0 1. Okay, if we change the third one 1 0 1 0 1. Fourth one 1 0 0 1 1. Fifth one 1 0 0 0 0. So these are the heuristic values 4 3 2 4 and 5. Go and search in the table. Next for this one we are having changing from the first bit 0 0 1 0 0. Next 1 1 1 0 0. Next 1 0 0 0 0. Next 1 0 1 1 0. Next changing the fifth bit 1 0 1 0 1. So these 5 4 5 5 2 are the heuristic values for this one. Okay, now among this one we are having the 5 1 2 3 4 5s are there. So we need to see the least values, this one and then this one. So these are the next to come in the, so among all these which is having the, if you are having all 4 or 5, then we have to consider the least value, that is the 5. So these two are the next. So at the level 1 these two, at the level 2 these two. Okay, so they're asking at level 1, so we got these two, At level 2 we got these two. Okay, now what is the variable assignment that makes the SAT formula true? Meaning that the for which values the SAT formula means it satisfies all. If I get all the ones for all the classes, then F becomes true. So now check where we are having all ones. So you see here 1 1 1 1 1. So for this 0 0 1 1 0 we'll get all the ones. Okay, so this SAT problem satisfied for this one. So 0 0 1 0 0 1 1 0 is your answer for this. Next, while coming to the group 3, when blind search looks at a node in the state. So we're having two types of searching algorithms. First one is the blind search, meaning that without knowing about the goal node. So these are the examples for the blind search. Otherwise we call it as uninformed searches also. So here we don't know about any goal node, just we'll concentrate about the neighbor nodes only. So it is interested in who is the neighbors of the node, and it is interested in whether the node is goal node or not. So whenever we are searching through the BFS, we will see what are the nodes connected to that one, and we will visit all the nodes. Next, whether it is a goal node or not, goal test will be performed. Like that, it will go. Next, while coming to the heuristic, this is also called informed search. Mainly concentrate about the some information will be provided regarding the goal node. So it will more concentrate about the goal. So it is interested whether the node is goal node or not, and it is interested knowing how close the goal node, how, how close the node appears to be. These are the two answers. The heuristic function for the node, so already we discussed, it estimates the how close in to the goal node. And next 15, when a goal exists in the state space, the algorithm hill climbing. So I think it's none of the above. It always finds. It's not finds always, I think so. I kept this none of the above as answers. What are the key differences between solution space search and state space search? So state space search always has a start specified, but in solution search no need of any start space, has to be specified randomly. And this path reconstruction may be needed in state space search but never required in the solution space search already. In which of the following search algorithms is the next node visited is always better than the current node? So already we saw that hill climbing and iterative hill climbing. Next, iterated hill climbing is suitable for configuration problems and problems where the start node can be random. Start node can be random. Next, while coming to the simulating linear, it begins with exploration and ends with exploitation. Coming to the fifth 20, the variable neighborhood descent is an extension of hill climbing, and this is attempts to escape from the local optima by using a different moves and function which is more dense. Okay, thank you.